Let's take a look at solving a system of equations through the process of elimination. Before we go through the steps, let's talk about what it means to add equations. So here I have the equations 2x plus y equals 4 and 2x minus y equals 0. If I were to add these equations together, I'm going to add my like terms. So notice that my like terms are already lined up. Both equations are in standard form, so my x terms come first, then my y terms, and then on the other side of the equal sign are my constants. If I were to add these equations together, I'm going to put a plus sign here, and I'm literally going to add or combine my like terms. So 2x plus 2x is 4x. Positive y plus negative y is 0. Those cancel. And 4 plus 0 is 4. I'm going to show that these cancel. Okay. So now we've added our like terms. From there, I've eliminated my y value, so I'm left with just x as my variable. I can now solve for x. If I divide by 4 on both sides, I get that x is equal to 1. This will be the first step in solving a system through the process of elimination. Let's take a look at one more example of how to add equations together. Down here I have the equations 2x plus y equals 7 and negative 2x plus y equals negative 1. So if I were to add them together, again, going to put my plus sign here to show that I'm adding. My like terms are already lined up, and I'm going to add 2x plus negative 2x. That's going to give me 0. So I can cross that out. That gets eliminated. Y plus y equals 2y, and 7 plus negative 1 is 6. Again, I now only have y in my equation, and I can figure out what y is. Divide by 2 on both sides, and I get that y is equal to 3. Now that I'm able to find one of my variables, I can then use this to substitute back into one of my original equations and get the other variable. Notice that the key here is that you have opposite coefficients for one of your variables. Here we had a positive y and a negative y. That allows those to cancel or be eliminated. In this second set, we had 2x and negative 2x. So again, when we add those together or combine them, the x's get eliminated. Right, let's look at an example. So we're going to solve the system by elimination. If you look at the equations, x plus 3y equals negative 2 and x minus 3y equals 16. We first have to see, do we have a pair of coefficients that are opposite? Well, in this case, we do. The coefficients of the y terms are already opposites. We have a positive 3 and a negative 3. When we add these equations together, those y terms are going to cancel. So now we can go ahead and actually add the equations. So here I'm going to add my x and my x, which will give me 2x. 3y and negative 3y combine to give me 0, so those get eliminated, and negative 2 and 16 equal 14. From there, I can solve for x. So I'm going to divide by 2 on both sides, and I get that x is equal to 7. Now I have part of my solution for my system. I'm going to take this 7 and I'm going to substitute it into one of the original equations to figure out what y is. I've chosen to substitute 7 for the first equation, x plus 3y equals negative 2. You could substitute it into the second equation and you should still get the same answer. So this becomes 7 plus 3y equals negative 2. I subtract 7 on both sides. I'm left with 3y equals negative 9. I'll divide by 3 on both sides, and that gives me y equals negative 3. I should show that I divided by 3 on both sides here. So the solution is 7, negative 3. We always want to make sure that our answer is correct, so next I'm going to check. I'm going to take my x and my y coordinates and I'm going to substitute them into both of the original equations to make sure that they work. So over here, when I substitute my x as 7 and my y as -3, I'm going to simplify this. This becomes 7 minus 9. 3 times -3 is -9. 7 minus 9 is -2. So it worked. Let's make sure the other one works. I substitute my 7 for my x, my -3 for my y. This becomes 7 plus +9. 7 plus 9 is 16. 16 equals 16. It worked. So we know that we're correct. Let's take a look at another example. In this example, we have an extra step. If we look at the two equations, -6x plus 5y equals 25 and -2x minus 4y equals 14, I don't have opposite coefficients for either of my variables. So in order to get opposite coefficients, I'm going to multiply either one equation or both equations by a constant. When you multiply by a constant on both sides, you're still creating an equivalent equation. You're just multiplying by usually the least common multiple so that you can get those opposite coefficients. So if you think about this, I'm going to look at the second equation and I'm going to multiply equation 2 by what number to get a pair of like terms with opposite coefficients. So I either need to get opposite coefficients for my x's or my y's. I'm going to go with my x's. If I multiply equation 2 by -3, that will give me a positive 6x. If I multiply by -3 on this side of the equation, I also have to multiply by -3 on the other side. So here I have that set up. I notice that I have this -3 in parentheses. I have this part of my equation in parentheses. I need to distribute that -3 to each term. So this now becomes -3 times -2x is 6x, and -3 times -4y is positive 12y. And on the other side, -3 times 14 is -42. So now I've created an equivalent equation, but now I have those opposite coefficients. So now I can add my equations together. So -6x plus positive 6x is 0. Those will cancel. 5y plus 12y is 17y. And 25 plus -42 is -17. I can divide both sides by 17 to figure out what y is. And when I solve for y, I get that y is equal to -1. Now I can go to my next steps of taking that y value and substituting it into one of my original equations to figure out my x value. All right. So my y value was -1. So I'm going to take that -1 and I'm going to substitute it. I've chosen to substitute it into the second equation. Again, you can substitute it into the first equation and you should get the same answer. So here, this now becomes -2x minus 4 times -1 is equal to 14. I'm going to solve for x. This becomes -2x plus 4 equals 14. Subtract 4 on both sides. I'm left with -2x equals 10. From here, I'm going to divide both sides by -2, and I get that x is equal to -5. Make sure you're showing that step of dividing by -2 on both sides. Now I have the solution to my system. So the solution is -5, -1. And again, I'm going to check it. I'll just show you all the way across here. So I substituted my x and my y values in. This became 30 minus 5, which is 25. So 25 is equal to 25. Here, I substituted my x and y values in. This became 10 plus 4, which is 14. 14 is equal to 14. Therefore, I have solved the system correctly. So the key with using the process of elimination is to get those opposite coefficients. So if you don't already have opposite coefficients, you're multiplying either one of the equations, like in our example 2. If I go back here, we only needed to multiply the second equation by -3 to get opposite coefficients. Sometimes you may need to multiply both equations by constants in order to get opposite coefficients, that is fine. So that is how you solve a system of equations through the process of elimination.